This year in algebra, we're going to learn about two different functions, linear and quadratic functions. We're going to be asked to do a couple different things, one of them being able to identify the graph of a linear and a quadratic function. The nice part about this is that they kind of give themselves away. Looking at the one on the left, you'll notice that it is a straight line. That means it is a linear function. The word line is in linear, so any function that is a straight line will be linear. The function on the right is a parabola. A parabola sort of looks like a U. In the word quadratic is the letter U. So any function that looks like a U will be quadratic. You're also going to be asked to identify the equations of a linear and a quadratic function. A linear equation will always be in the form of y equals x, and a quadratic function will always be in the form of y equals x squared. The biggest difference being that a quadratic function has a power of 2. If you're asked to identify the x and y intercepts of a linear or quadratic function, you need to first be able to identify where is my x-axis and where is my y-axis. An x-intercept is simply where the graph crosses your x-axis. So if you look, this graph crosses my x-axis at -1. So to create the x-intercept, I put a -1 under the x. The empty spot becomes a 0, so my x-intercept is -1, 0. Looking at the quadratic function, it's kind of different because a quadratic function touches your x-axis 2 different times in this situation. It touches the x-axis at -2, and it also touches the x-axis at 1. That means my x-intercepts are -2, 0, and 1, 0. Looking at my linear function crosses my y-axis at 3. We put a 3 under the y, fill the x in with a 0, so my y-intercept is 0, 3. This quadratic only touches the y-axis one time at -4, so we put a 0 under -4, which makes my y-intercept 0, -4. We need to be able to identify the slope of a linear function. We always go left to right when we're trying to find the slope. As I go left to right, my graph hits right here. My blue line hits my graph right here and it goes up. Going up means it has a positive slope. A linear function with a positive slope will have the form of the equation y equals x. Looking at the linear function on the left, when I go from left to right, it hits the graph and it goes down, which means it has a negative slope. A linear function with a negative slope will always be in the form of y equals -x. I use the term slope loosely when we talk about quadratic because it doesn't necessarily have a positive or a negative slope. But if we look at these two graphs, we can tell that they are very different. This one opens up and this one opens down. I like to make smiley faces out of them. This is a happy quadratic, which means it's going to have a positive quadratic. So it will be in the form of y equals x squared. This one over here is a sad quadratic, so it is negative. So it's going to be in the form of y equals -x squared. Let's review what we've talked about. This is a straight line, so it's linear. It crosses my x-axis at 6, which makes my x-intercept 6, 0. It crosses my y-axis at 3, which makes my y-intercept 0, 3. And going from left to right, it has a negative slope. So it's going to be in the form of y equals -x. We're going to ignore 0's domain range right now. Looking at this function, it is a straight line, so it is linear. It crosses my x-axis at 2, so my x-intercept is 2, 0. It crosses my y-intercept at -4, so my y-intercept is 0, -4. When I go from left to right, the graph goes up, so it is a positive slope, so it's in the form of y equals x. This graph is a quadratic because it looks like a U. It crosses my x-axis at -1 and 6. And my y-axis at -3. It is a happy quadratic, so it's going to be positive. This graph is a quadratic because it is a U. It crosses my x-axis at -5 and 1. It crosses my y-axis at 2. It is sad, so it's negative, so my equation would be y equals -x squared.